Bill Nye the Science Guy.
Beer, 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 beer. 第二是科学家。
科学定律与你培生。
第二是科学家。
惯性是物质的性质之一。
第二是科学家。
倒数7秒，计时开始。
第二是科学家。
So this video is about antimatter. Now you might be asking yourself, what is antimatter? Well, let's take a look. Now obviously that was a joke, but entities do emit positrons, which are a form of antimatter. And now we're going to talk about that a bit more. So here Claire's going to draw some matter for us. So she's going to start with the nucleus and put some protons in there, and then she's also going to add some neutrons in there because obviously the nucleus is made up of protons and neutrons. And this is just regular matter she's drawing right now. So after she draws the nucleus, she's going to make an electron cloud. So we have these electrons outside of it, just normal matter stuff. You got your electron cloud. She made a little mistake there that she's erasing. And so now she's going to show antimatter, which, as you can see, she's changing all the charges. So in the place where electrons would normally be, she has positively charged electrons, or as we call them, positrons. And then in the place where protons would normally be, she's made those negative. And so that's basically what antimatter is. It's just, it's the same as regular matter, except for all of its charges are opposite. And so now she's basically going to show what happens when it collides with normal matter. So, she's putting an electron there, and bursts of energy are being released because when normal matter and antimatter collide, they kind of react with each other, and all of their mass is converted completely to energy. And we're going to talk a lot more about, boom. We're going to talk a lot more about all of that later on in this video. So antimatter exists in our natural universe, except it doesn't exist anywhere near Earth because, as we mentioned earlier in our little doodle, when antimatter and matter collide, massive amounts of energy are produced, and thus we would cease to exist. So scientists, since, like I said earlier, antimatter doesn't occur in massive amounts on Earth, scientists use accelerators to collide particles to collide particles and make antimatter. An example of this is the Large Hadron Collider, in which scientists use superconducting magnets to shoot particles at one another and make them form antimatter. Because antimatter is formed in places where radiation occurs. As we mentioned earlier, the large amounts of energy are generated when both matter and antimatter meet. When antimatter and matter collide with one another, it's the release of energy of 2 photons, high energy gamma photons, and the energy released by that is incredibly large. When 1 kilogram matter and 1 kilogram of antimatter meet, the energy release is equal to 43 megatons of energy, which is more than thousands of nuclear bombs. So, it's a safe thing. To protect this from happening when scientists are experimenting with it, they keep them in vacuums or like magnetic chambers to make sure they do not touch any matter, because if they did, we'd have a big problem on our hands.
During the Big Bang, there was the creation of both matter and antimatter. But whenever examining our solar system, we notice that it's made up of mainly matter. So scientists theorize that the universe is divided into regions that are made up of purely matter or antimatter. This helps explain why Earth and the solar system it's located in is made up of mainly matter. To support this theory, there is something called the CPT theorem, where C stands for charge, P stands for parity, which is like space, and T stands for time. How this theorem explains how antimatter is the exact opposite of matter, because in theory, antimatter is the inversion of matter's charge, parity, or space, and time. But whenever examining the antimatter created at CERN's Large Hadron Collider, scientists noticed that is an issue with the C and P of that theorem, which is called the CP violation. And basically what this means is that whenever scientists theoretically invert charge and parity, they notice that it doesn't match up with what antimatter is observed to be and what antimatter is theorized to be, the exact opposite of matter. The CPT theorem is used to explain and support a bunch of other theories, such as the theory that there is a little bit more matter than antimatter within the universe. And it also supports another theory created by the theoretical physicist Massimo Valletta that antimatter and antimatter attract, matter and matter attract, but antimatter and matter repel each other. And this theory ultimately supports the idea that the universe has different regions that are only made up of matter and antimatter, because the matter attracts other matter while repelling the antimatter around it, creating its own distinct region within the universe. Because matter and antimatter repel each other, there does need to be some more research done on how to effectively collide matter and antimatter in order to produce energy. Because antimatter and matter collisions yield such high energy, they have a variety of applications. One of their potential applications is space travel. NASA is currently designing an antimatter engine to be used in its upcoming Mars mission trip. One of the current designs for a small antimatter interstellar probe is designed to reach speeds up to 1/10 of a light speed. That is 30,000 kilometers per second. And the fastest spacecraft ever built, Voyager 1, reached speeds only up to 17 kilometers per second, meaning that an antimatter-fueled spacecraft would be around 1,800 times faster than what we can create today. On top of this, antimatter can also be used to improve the medical field with what is known as PET scans. PET stands for positron emission topography. And as we said before, antimatter's electrons, which are positive, are known as positrons. PET scans are used to image the body's metabolic processes. So with further research, scientists will be able to better understand positron emissions in order to create higher resolution imaging. Overall, antimatter has really great potential to become an alternative energy source. Even though antimatter and matter collisions ultimately destroy matter, the amount of energy gained from such a small destruction of mass is phenomenal. Especially as other energy sources such as oil are quickly depleting, the high energy yields of antimatter become extremely worth it. So to conclude, antimatter with further research can become a really great alternative energy source.